Looking at this image of workers manually loading harvested sugarcane, the physical toll of traditional farming is immediately clear. Indian agriculture is operating under compounding pressures: an acute shortage of manual labor, high rates of chemical waste from hand spraying, and a staggering national demand for food. We live in an era where precision agriculture and artificial intelligence are highly developed, but these tools remain largely confined to corporate silos and research facilities, miles away from the fields where they are needed. This creates a last-mile barrier. Building a capable aerospace vehicle is only half the challenge. Maintaining and operating that technology in a remote village requires a logistical setup that most farmers simply don't have access to. Solving this requires a shift in focus. To bridge the gap, the network moves beyond the individual drone and establishes the localized ground-level infrastructure needed to keep it flying. This high-tech bridge to the rural soil is the Meghdev Drone Station network. The Meghdev Drone Station is a modular, one-acre airport for drones. It functions as a localized command node positioned directly within the rural community. Each station follows a standardized footprint: a DGCA-compliant operations pad, independent solar energy arrays, and 6 simultaneous charging bays to ensure the fleet stays active. This is the Vigo agricultural spraying drone. It is a heavy-duty 6-arm machine with a central payload tank capable of carrying 10 to 70 liters. This capacity allows it to cover vast tracts of land with a fraction of the labor used in manual methods. Safety depends on constant communication. The station maintains a dual connectivity protocol, utilizing a primary 5G link with an automatic VSAT satellite backup to ensure uninterrupted telemetry. This connection enforces the no permission, no takeoff protocol. Before a flight, the station requests an arming token from the government's digital sky server. The server issues a secure digital key that physically unlocks the drone's hardware. Without it, the drone cannot fly. This entire physical setup serves a specific purpose. It is a high-resolution sensor network. Every flight converts the physical landscape into a stream of raw, actionable data. By planting this infrastructure, a village becomes a regulated, high-capacity node on the national airspace grid. Every flight launched from the pad feeds the agro-AI ecosystem. As a drone sprays, its sensors generate a virtual farm, a digital twin of the terrain that mirrors the physical field in real time. This platform tokenizes farmland into measurable units. The 1 square meter tile is used for overall planning. Zooming in, 1 square centimeter cubes track individual plant health for precise nutrients. Finally, 1 square millimeter pixels detect biochemical signals of disease at the leaf level before they're visible. This data flows from the drones into the central HAL ERP platform. The system processes these millions of data points to generate predictive yield models and automated alerts. This information also reaches up to national supply chains. Agri-input companies use this data to optimize their inventories based on the soil's actual needs. The station acts as a physical funnel. Chemicals and fertilizers are delivered to the hub, and drones apply them exactly where the AI dictates, removing the need for traditional middlemen. This dual pipeline replaces seasonal guessing with a system of continuous millimeter-scale measurement. From the individual farm, the network scales to the district level. A multi-tier franchise model connects Grand Panchayat centers to large FAME hubs that oversee entire regions. Each hub is an independent economic engine. Beyond agriculture, the stations generate revenue through drone rentals, repair services, and non-seasonal work like land surveying and local logistics. To speed up adoption, government subsidies like the Kisan Drone Yojana are integrated directly into the station's software, reducing the financial barrier for new operators. This transition also changes the nature of rural work. Local youth and women are trained as DGCSA-certified pilots and technicians, moving from manual labor to skilled digital roles within their own communities. The impact on food security is measurable. AI-based farming trials in Maharashtra have already demonstrated yield increases of up to 40% in crops like sugarcane. The long-term vision is a decentralized infrastructure grid that connects thousands of these rural nodes into a single cohesive network. Placing these high-capacity aerospace nodes directly in the village integrates rural communities into the national grid, providing them with the same technological tools used in the world's most advanced research centers.